This video provides step-by-step instructions for you to create this snap gauge using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In Segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In Segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we will review the engineering drawings of this part called a snap gauge. Let's start by identifying the views provided in the drawings. This drawing shows 2 standard views used to describe the shape and size of this mechanical part. First, an isometric view shows the shape as a 3D pictorial to help us visualize the part. The orthographic view shows 2 principal views. In the lower left corner, the front view. Aligned directly above the front view is the top view. There is also a detail view. This added view is used to help us clearly see the shape and size of a small feature on the drawing. When preparing to make a feature-based model, we need to identify the basic shapes and features. The front view contains a rectangular shape with a semicircle on top. The center of the semicircle is coincident to the top edge. One end of the semicircle is tangent to the back edge. The other end is coincident to the top edge. At the center of this semicircle is a hole. On the front edge, there is a rectangular slot with chamfered inside corners at the front, and the slot ends at a semicircular hole. The slot is centered at the midpoint of the front end. Next, let's look at the dimensions and notes. First, the measurement units are in millimeters. The material thickness is 15 millimeters. The length is 100 millimeters. The height is 40 millimeters on the front end. The top arc has a radius of 30 millimeters. The concentric through hole has a diameter of 25 millimeters. The slot has a height of 15 millimeters and a depth of 35 millimeters with a semicircular end. The fillets have a radius of 10 millimeters. The chamfers are cut at a 45-degree angle at a distance of 5 millimeters from the corner. The material is steel, and the mass units are set to grams. Before we model the part in Onshape, we have to establish our design intent. For this project, we intend our model to be flexible to possible design changes and update predictively without errors. To start, we need to identify all the features that may need to be changed or revised during or after modeling the part. On this part, the slot on the front will be used as a gauge to provide quick measurement for material thickness. A go, no-go gauge. So we may need to later change the design to have a different slot size. When the slot height is changed, the slot opening should remain centered on the front of the gauge. When the slot height is changed, the front height of the gauge should also increase by the same amount. Next, we need to identify the features that should remain unchanged if those items are revised. The length and thickness should remain the same. The size and location of circular features will maintain their current relationships. The size and location of the fillets and chamfers will remain the same. When creating the model, the choice and the order of applying constraints will determine if the model will update predictively. So when the slot and nose height are changed, the part will update without errors. Before we model the part in Onshape, let's preview the steps in the modeling process. Use the drawing to identify the profile or closed shape that we'll use for the base sketch. For the snap gauge, we choose the front view. Because this is a flat part, this view defines most of the features and locations. Choose the desired isometric view orientation for the part in the Part Studio. We want the same orientation as shown in the drawing. So Sketch 1 will be placed on the front sketch plane. Choose the location for the origin in Sketch 1 to constrain the sketch to the plane. We will place the origin coincident to the corner of the part. Complete Sketch 1. Extrude 1 will add the thickness and complete the basic shape of the part. Chamfer 1 will cut the front edges of the slot. Fillet 1 will round over 2 corners on the body of the gauge. Create the base sketch. I've started a new Onshape document and named it Snap Gauge. Before starting the sketch, I want to check my workspace units. Make sure the length is set to millimeters and the mass is set to grams. Use the green check to accept. I'll start a new sketch in this part studio. Click on the front sketch plane. Use N on the keyboard to view normal and P to turn off the visibility of the sketch planes. From the toolbar, choose Corner Rectangle. Click coincident to the origin to start the rectangle, stretch to the left and click. Enter 100 millimeters for the length and 40 for the height. From the toolbar, choose Center Point Arc. Click on the top line of the rectangle. Then click on the corner of the rectangle to start the arc coincident to this point. Drag the arc over and click again on the top line of the rectangle. Next, enter 30 millimeters for the radius of the arc. All of the lines should be black to indicate they are fully constrained. Next, from the toolbar, choose Center Point Circle. Click on the center point of the arc and drag the circle out and click. Enter 25 millimeters for the diameter of the circle. Use Escape to end the command. Next, we will create the slot. From the toolbar, choose Corner Rectangle. Click in the middle of the existing rectangle and create the new small rectangle without touching any other lines. Enter 35 for the length and 15 for the height. Next, we need to align the center of the slot with the center of the nose. From the toolbar, choose Point. Move the cursor on the front edge until you see the yellow box light up and snap the point to the midpoint. Now we can constrain the slot to the front. Choose the midpoint constraint from the toolbar. Click on the point we just added to the nose. Then click on the midpoint of the front of the slot rectangle. They should snap together as this constraint is applied. This slot has a semicircular arc at the end. We will add this next. Using the center point arc, click on the back of the slot, then one end and then the other. Use Escape to end the command. We have now completed the base sketch. Use the green check to accept the sketch. Right-click the mouse and choose Isometric View. Create the base feature. We can now create the base feature from the sketch. Click on the Extrude tool in the toolbar. This is going to a new feature. For the sketch region, click on the parts of sketch 1 that we want included. It should be extruded forward. Set the depth at 15 millimeters. This looks correct, so use the green check to accept. First, we will add the chamfers to the front edges of the slot. Click on the chamfer tool in the feature toolbar. For the chamfer type, choose Distance and Angle. Set the distance to 5 millimeters. Set the angle to 45 degrees. Click on the bottom and top edges of the slot. This looks correct. Click the green check. Next, we will add fillets to round over 2 corners on the body of the gauge. Click on the Fillet tool in the feature toolbar. Set the radius to 10 millimeters. Click on this outside corner of the gauge and this inside corner on the top. This looks correct, so click the green check. The snap gauge is now complete. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass unit should be set to grams and the material set to steel. If the size and shape of your model was completed accurately, the mass should be 503.624 grams. Let's look at this process step by step. First, open the document that contains the model of the snap gauge. Next, check the workspace units and make sure that mass was set to grams. Next, set the material to steel. I'll go to the part in the parts list and right-click and choose Assign Material. In this case, we're searching for steel. As I scroll through, I'll see that there's a number of types of steel available, but I want plain steel. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 503.624 grams. If this was your result, then your part is accurate and matches the specifications. If not, we can troubleshoot to locate the step where you made an error. First, locate the rollback bar in the features list. We're going to roll back to Extrude 1 and examine the mass property. Slide the rollback bar up until it is below Extrude 1. The mass property is now 507.442 grams. If your value doesn't match, you have an error in the base sketch or Extrude 1. Next, slide the bar down to add back chamfer 1. The mass property is now 504.498 grams. Last, slide the rollback bar to the end adding back fillet 1. The mass properties for your part should have a total of 503.624 grams. In this segment, we will make revisions to the snap gauge. We will start by reading the revision drawings to find which features need to be changed. First, the height of the slot has increased 5 mm from 15 to 20. Along with this, the nose height has also been increased by 5 mm to 45 mm. I notice that when these changes are made, the slot should remain centered on the nose end. A 2 mm radius fillet has been added along the outside edges and the hole. You can check your revised part. It should have a mass of 528.079 grams. I've opened the Onshape document called Snap Gauge to make revisions. I know that the dimensions that need changes are in Sketch 1, so double-click to open it up for editing. Double-click on the dimension for the slot height. Change this to 20, then hit Enter on the keyboard to accept the change. Next, double-click on the dimension for the nose height. Change this to 45. To see what this change will look like, use the Final button to preview the result. Click on the green check to accept. Next, we will add the fillets. Click on the Fillet feature in the toolbar. Set the radius to 2 mm. Click on an outside face of the part. Notice that with tangent propagation turned on, the fillet will be applied to edges tangent to the face. Notice this edge on the bottom needs to be selected. Click on the edge. Click on the edge of the hole on both sides. End the command. With the revisions complete, let's check the mass properties now. It should be 528.079 grams. If your result matches this, you have revised the part accurately.